Larry Flandreau, who was working at JPL in the summer of 1965, looking for ways to use the, see when a planet's orbiting the sun, it's moving, right?
Yes.
In fact, in the case of the Earth, it's moving 30 kilometers every second around the sun. You don't know it, but in fact it is. And if a spacecraft flies by a planet, it is the planet orbiting, it flies by, the planet will kind of give it a big flip, like a slingshot. And so he was looking for slingshot opportunities, gravity assists they're called, and discovered that if you launched a spacecraft in 1977, the planets, Jupiter, Saturn, Uranus, and Neptune, are all lined up so boom, 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 boom. Because every 176 years they get all together on the same side of the sun. And so that the magic year was 1977. He discovered that in 1965. And right away, people at JPL, various people at JPL began designing what can we do to take advantage of this opportunity to make it to Neptune. Because by swinging by all the planets, it takes only 12 years to get there rather than 30. So that's a big difference. So that's where the idea came from. A lot of people worked on it, and out of that came Voyager, which was a mission launched since 1977. But at that time, it was its main objective was just to get to Saturn. Because spacecraft didn't last very long, so they decided they would not commit to a 12-year journey because it might not work for 12 years. And so they committed, NASA committed to a 4-year journey to Saturn, 2 spacecraft. So that if one failed, the other one could do it. And both the spacecraft are still running today, 40 years later.
Yeah. So the original Voyager, was it hard to convince NASA to fund the project?
Well, the original mission was called the Grand Tour because it did all 4. There were 4 spacecraft to make sure you could cover all the outer planets, including Pluto. But it was too expensive. And so it was canceled in January, roughly December of 1971. It was canceled, and a month later, JPL went back with a simpler mission, which was had to only go to Saturn. But it would be launched in 1977 so that if everything worked, it could go on.
Interesting. So apparently the name Voyager was actually selected in a contest. So what did you want to name the mission?
I really don't remember. I'm not sure I even made it was really open to, I don't know who it was open to, I don't even remember that anymore. But this was about a year before launch, as I remember. Before that it was called Mariner, Jupiter, Saturn, because it was a 4-year mission to Saturn. But it was decided, let's call it Voyager, because hopefully it will last longer and we will actually go further than Jupiter and Saturn.
Interesting.
But I don't remember who proposed the name or anything like that anymore.
So did you have like another name for the spacecraft in Voyager? Like the Curiosity rover is known as the Mars Science Lab at JPL.
Well, it was originally known as Mariner, Jupiter, Saturn 77. That was its initial name.
But did you call it anything different?
No,
at JPL?
that's what it was called, MJS 77. Okay. MJS 77, that was what it was called.
So Voyager has entered the heliosphere. Has it ever left it yet?
Oh, the heliosphere is created by the sun, and the sun has a wind blowing radially outward from it. Do you know that? Do you know about the solar wind? 1,000,000-mile-per-hour wind streaming out in all directions from the sun, and that wind creates a huge bubble around all the planets, and the Earth and all the planets are inside this bubble. That bubble is called the heliosphere, because the sun is helios, of course. And so, so what was your question? That's what the heliosphere is. Your question was?
Has it truly left the heliosphere?
Yes, it left. The Voyager 1 left the heliosphere on August 25th, 2012. So almost 5 years ago now.
So how about Voyager 2?
Voyager 2 is still inside. It moves more slowly because it turns out that Voyager 1 went by only Jupiter and Saturn, and that meant it could go a lot closer to the those two, when they got a much better slingshot effect, so Voyager 1's faster. Voyager 2, we left in the plane, it didn't fly as close to Jupiter and Saturn, so it didn't gain as much energy, so it's not moving as fast, about 10% slower.
Mm-hmm.
And so it's not outside yet, but could happen anytime, next couple of years.
So do you think that that the Voyager 1 has truly is truly in interstellar space?
It's in the space, what that means, what does it mean, interstellar space? Well, the bubble, inside the bubble, the magnetic field comes from the sun, the wind comes from the sun. Outside, the magnetic field's in the Milky Way galaxy, and the wind comes from the explosion of other nearby stars, supernova.
Mm-hmm.
So there's a distinct difference between what's inside and what's outside. And that what is outside fills the space between every star has an astrosphere, so the space between, which is huge compared to the bubble, the space between is huge.
Yeah. Did you ever think that that Voyager would ever last this long?
Well, we hoped, but there was no evidence. You see, Joe, how old was the space age when Voyager was launched? Do you know? When did the space age begin? Do you remember the mission that began it?
It was.
How about Sputnik?
Yeah, that was
The
it,
Russians,
yeah.
that's right, 1957, 20 years. So when Voyager was launched, there was that whole, I mean, there was nothing that had lasted 20 years at that point, because there was hardly anything could last 1 or 2 years at that point. And so we hoped that by building a lot of redundancy into the spacecraft, that have backup systems, so if a primary system failed, it would automatically switch to the backup. The power supply is very important. How do you have a power supply that lasts 40 years? You have any idea how you make a power supply that lasts 40 years?
Well, there's solar and.
Solar would last that long, but it's not very near the sun, so
Yeah.
it's it takes bigger and bigger panels. You know how much
Mhm.
sunlight there is at Neptune compared to at Earth?
Oh, like very little, maybe like 1%.
Yeah, it's 30 astronomical unit. The Earth's at 1, so it's
Yes.
30 times as far from the sun.
Oh,
And
so-
the sunlight goes down like the square of the distance, so it's 30 squared, 900, 1/900th
Wow.
of the amount. So the solar cell pattern would have to be 900 times larger.
Yeah.
Okay, so what you do is you use the natural radioactive decay of plutonium-238. So when things are radioactive, they get thermally hot. So they sort of got very hot, and then you bolt a lot of thermocouples, which are solid state devices that when you heat one end and cool the other, generates electricity.
Mm.
And so it's a very robust, long-lived battery. Not a battery, really, it's a radioisotope thermoelectric generator. But we every year we have 4 watts less than we had the year before, so slowly but surely, we won't have enough power to power the spacecraft, about 10 years from now. So we can run for about another 10 years.
Interesting. Now that you've had about like 40 years of journey of the Voyager
Yeah.
to reflect on, what other like instruments do you wish you had put on it?
Well, it would be nice if we had modern instruments, because the instruments we have on there are over 40 years
Yeah.
old, so they're very primitive compared to. Do you realize that your cell phone has 240,000 times more memory than Voyager and its
Wow.
computers?
Wow.
That your cell phone has a computer that's 100,000 times faster than the computers in Voyager? These are very primitive, but they worked. So the spacecraft, these were the first automated spacecraft that took care of themselves, switched to backup. If it lost orientation, it would go through a pattern to find itself again. So these are the first spacecraft, always with these very primitive computers.
Interesting. So, what do you think surprised you the most about the mission?
How diverse all the moons and planets are. And before Voyager, the only active volcanoes were here on Earth. None of the other planets had active volcanoes that we knew of. Venus used to have, but it doesn't have right now. Yet when we flew by Jupiter, it has a moon called Io, which is about the same size as our moon, 10 times the volcanic activity of Earth.
Wow.
Wow.
How'd that happen,
Yeah.
huh? Before Voyager, the only known liquid water ocean was right here on Earth. None of the other planets have liquid water oceans. And then we flew by another Jupiter's moon called Europa and saw an ice crust on what almost surely was the liquid water ocean beneath, and indeed, a subsequent mission proved that there's a global ocean beneath the icy crust of Europa. So time after time, things which we thought might be unique to Earth or whatever, we found were not. That these but that's not that their volcanoes on Io are the same as the ones on Earth, they're different, but they're volcanoes. And the last object we visited before we started our interstellar journey was the moon of Neptune, called Triton. And Neptune's far enough away, as I said, that it's very cold out there. It's only, you know what the absolute zero is?
Yeah.
It's the coldest anything can get. It's about minus 273 degrees centigrade. Its surface of Triton is 38 degrees above absolute zero. Yet there are
Wow.
geysers erupting from its icy polar cap.
Incredible.
Not exactly what you expect.
Yeah. So, what do you think you're most proud of about the mission?
Well, just how it's really given us a totally new view of the solar system and how planets form and how they evolve.
So yeah. What has been the most surprising thing about the mission besides the long nativity?
Well, I gave you a lot of surprises, right? You
Yeah.
know, before, and I'll give you another one. Before Voyager, the only known nitrogen atmosphere was here on Earth. Of course, there's oxygen
yeah,
as
yeah.
well, you know, but it's mainly nitrogen. None of the other planets have nitrogen atmospheres. But there's a moon of Saturn that does. It's called Titan. It's about as large as the planet Mercury, except it's in orbit around Saturn, so it's a moon. But it's the only satellite that has a really dense nitrogen atmosphere. And that atmosphere has methane in it rather than oxygen. You know where the oxygen came from in our atmosphere? Why do we have oxygen in our atmosphere?
It was from the early life forms.
Right, correct. Microbes. Even today, microbes create a lot of oxygen. And but there's no oxygen in Titan's atmosphere. Instead of oxygen, there's methane. Now, do you know what methane is? You see it. You did say it's in your house. It's in you see it every day. It's natural gas.
Oh.
Every time you turn the stove on, you're burning methane. And that's what's in the atmosphere of Titan. And so instead of having smog, which are like oxides here, and all the bad things in our atmosphere are oxides. Well, they're not oxides there. What's there are organic compounds made in the atmosphere. And they rain down on the surface, create lakes, but they're not lakes of water, they're lakes of methane and ethane and other hydrocarbons, all but the methane made in Titan's atmosphere. So another big surprise.
Cool. So, do you think there are some things that everyone in general should know about Voyager that maybe people they really should know, but some people they just don't realize about Voyager?
Well, I think I've given you some. I don't think a lot of people really understand how much it changed our view. As we were discovering these things, they realized we were discovering a lot, but in retrospect, they really just changed our view of the solar system and how it formed, how planets form, how moons form, and how they evolve. The fact that they're still active. The Earth is active, we know that because of earthquakes, but it's not just the Earth that's active. Even little moons today are active.
Do you think that there will ever be another mission like the Voyager mission?
I hope someday there'll be an even faster mission so it can get out there more sooner than 40 years and get further. But most of the planetary missions in the future will be like Cassini right now, which is in orbit, because you want to spend a lot of time flying by all those moons, and you want to just orbit Saturn and explore the moons. And that means that you're never going to escape the solar system. You're actually going to dive into Saturn. That will be the end of Cassini in September.
So, do you think in the future that maybe people will want to try to just do another Voyager mission, or they,
Interstellar probe is what
Right,
we
right.
call it.
or do you think they'll just wanna stay here in our solar system, learn more about that, and then maybe not try to explore way beyond into maybe a new solar system, or,
Well, you have to realize space is really immense.
yes.
It will be 40,000 years before Voyager is closer to another star than it is to the Earth.
Mhm.
And at that point, it's still not gonna be very close to the other star. It's gonna be more than a light year away. So we do not have the technology to get anywhere near another planet, another star even, much less
Yeah.
another planet, and to send the data back. Because that same R squared dependence really becomes a huge number if you're, many astronomical units away.
Okay. And just that kind of final question, do you prefer Voyager 1 or Voyager 2? And just, which
Well,
one do you
they
think?
both contributed, they both
Yeah.
made discoveries, and the fact the two of them certainly really created a much more robust program than the one alone would be. For instance, after Voyager 1 flew by Jupiter and discovered the volcanoes on Io, then we reprogrammed Voyager 2 so when it flew by, it could actually image the volcanoes erupting. And so we have some images of erupting plumes on the bright limb of the moon. This is my favorite mission, I can say, because it's been a major part of my life for the last, I started working on this in 1972. So what is that now, 45 years. So it's a special mission. The kitchen sink's nice when you have a flat bottom. And you think of the water coming out as the sun. Where it hits the bottom is where the sun is. And you see this all the time when you do this. Let me put it kind of over here. You notice the water, there's a thick ring of water out here, but in the middle it's very thin and very fast, and it's radial. It's always moving radially outward. So the water there is moving there just outward. It's moving faster than the speed of waves on the surface, so it's in that sense supersonic. But it keeps getting thinner and thinner as it spreads out. At some point, it can't push anymore, and it abruptly slows down in a shock. And once it slows down, the water can turn and go down the drain. Notice the water isn't turning in here.
Yeah.
It doesn't know there's anything out there because it's moving so fast that no signal can get back upstream, like in a supersonic aircraft. And Voyager 2 is in the thick part right now. It's trying, and outside is here. That's Voyager 1 is outside, where there's no more wind turning. But inside, Voyager 1 is seeing the wind turn to go like this. Wind has been radial the whole time until we crossed this shock, and then it started turning, just like the water's turning.
So what is it turning towards?
It's a tail, it creates a tail behind
Yeah.
the ears.